Hi everyone, my name is Abel Gray Cantoma. I'm from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or you can call me, okay? I've covered up to 25 different softwares on my YouTube channel. They are very much available on that channel. Just go down below the description of this video. You'll find a link to that channel. Make sure you visit the channel and actually keep yourself busy, okay? Today I'm going to briefly be showing you how to come up with your general arrangement. I have done a lot of videos on general arrangement already, but if you go down below the description of this video, you'll find a link to that channel. Just visit the channel and then you'll find that video there. Okay, today I'm going to be showing you how to come up with general arrangement. Like I said, I have done some in the past. Okay, this is the drawing that was given to me. This is the ground floor. This is actually the first floor. Okay, now but if you see, you discover that from this drawing, this is from the architect, you discover that whatever I have here on the ground floor is exactly what I have here on the first floor. So this is actually a 2-bedroom flat. Here we have a staircase where you just come in and enter to the other floor, which is actually above. Okay, so since what I have here on the ground is the same thing as what I have on the first floor, I'm just going to need just one plan. Okay, so I'm going to just pick one of this, which will serve for both my ground floor and my first floor. So I'll copy with base point. I'll click anywhere and then I will highlight the drawing and I'll click. So I'm going to paste this drawing in an existing drawing environment that I already have, that I have done with AutoCAD. So I'm going to paste this drawing here. Okay, so I always like to have another extra copy down below so as for me to view whatever I have there. Okay, good. Now the next thing I'm going to do, I'm going to lay off some of the ones what I actually want to have here. Okay, okay, so I don't need all of this. I don't need this. Let me lay on. Lay ISO, that's to isolate a layer. Let me isolate this. Okay, the walls and the dimensions are actually in the same layer. So I have to manually pick this one by one to delete, since they are in the same layer. Okay, that's why it's important for your drawings to be in layers, so you have all of your dimensions in different layers and all of that. It makes your work much more easier and faster. So I have covered how to use AutoCAD tools in my YouTube channel. Just go, you actually find them there, how to make use of AutoCAD tools. Okay, and then how to the training is actually very much beginners friendly. You can register with us to learn any of the softwares. Just DM me on my WhatsApp. You're going to see the full list of the softwares and how the training is. Like I said, they are not on layers, so I have to manually delete all of these dimensions, which is actually going to take much of my time. So you can see the importance of AutoCAD cannot be overemphasized. It's good for you to actually have a good knowledge of AutoCAD because most times your drawings comes in either DXF or DWG format from the architect. Okay, so that is why AutoCAD is very important. Okay, I always like to divide my screen into two. viewport configuration, 2 vertical. This is actually AutoCAD 2020. But the good thing about AutoCAD is once you have good knowledge of AutoCAD, irrespective of the version, you should be able to use any other version of AutoCAD. My own opinion, I think. Let me take out all of this because I'll take out the grids. Okay. Now to come up with general arrangement, you don't need doors, you don't need windows. Okay, so there should be no opening in your general arrangement. Okay, I'm just trying to check the span. Okay, the span is not that much, so I think this design is not very good. It's not actually going to be very brainstorming. It's not going to be brainstorming. It's actually going to be very easy to achieve. Okay, so fine, what I'll do now is to join these lines together. Okay, okay. Okay. I'm gonna make this video as brief as possible. Okay, because I don't want to bore any of you. Oh my god, what just happened? Okay, this is a dining, this is a kitchen. So what I'm going to do is this okay, this is a sit out. Okay, let's view the architectural drawing. Okay, but there's, yeah, we are going to provide a beam that will go this way. So we're actually going to have a wall coming this way. All right, mind you, as an engineer, 2 engineers to come up with one general arrangement. With if you give one archi drawing to 2 different engineers, they cannot come up with the same exact general arrangement. So it boils down to your experience, and then yeah, it boils down to your experience on design, on site, and all of that. Okay, so the main thing is, as you are doing your design, because your general arrangement would determine whether this design is going to, or the project is going to be economical or not. So your design has to not just be safe alone, but your design has to be economical. Okay, so like I said, it boils down to your experience. So that is it. Let me check this. What is the span here? Okay, the span is not that much. Okay, so mostly I take out all these bathroom walls and toilets. Okay, I take them out most times, even this store, just to make this more economical, because if you check this span, it's actually not very large. Okay, this is a very small span, but here I actually have a seat out here. So you may have a different opinion over on this. Okay, so like I said, two engineers cannot have the same general arrangement on one architectural drawing. It's not possible. But the both of them can, but the two designs can be safe. But one thing for sure is that one is going to definitely be more economical than the other one. Okay, so but there are basic things you need to put in order when coming up with your general arrangement. Okay, but like I said, this design is actually what we have on the ground floor is actually the same as what we have on the first floor, so that makes our design much more easier to come up with. Our general arrangements much more easier rather. Okay, I don't want all these lines broken this way. I think this is going straight this way, so I'll just use a tool called extend. Fine, this is what I have, a single straight line. All these ones are broken, so I always like to have a single straight line. It makes your work much more easier, faster, and even neater. Okay, so I think some of these walls are not the same. Let me check. You can see this one is 150, this one is 230, I think this one is 150. Okay, so you must take your time to actually study the drawing very well. Okay, I don't need this, please. Okay, if you look at this from the drawing, so there is no, I think there is no slab here, because what we have on the first floor is also the same. You can see here and here, so just vegetation, so there is no slab here, there is also no, so it's not slabbed. Okay, so this is actually void all through. So let's go back to the drawing. Okay, here let me just have a straight line. One, this is 150. Let me make it, I'm going to make it go make it 230, 115. Here also I'm going to make it 2 thirds, 75 at the middle. I'll take out this line, this one, and I'll set 115. Okay, so this is what I have. Let me take out this. I'll extend it here. Oh, good. Okay, 75. Okay, let me see something here. This is actually the main wall is actually here. Okay. Okay, let me see something. Come and let me do something quickly just to confirm what I have here. Okay, this is 1150. Okay, I think I'll make this one come this way. Okay, straight this way, and here. So this sit out is going to be like a cantilever. Okay, then here as well. I can as well make the whole of this cantilever. The entire span is just around 4 meters, not even up to 5 meters. So if I take it center to center, this is what I'm going to have. 4780, which is not bad. So I'm going to have a cantilever here. Okay. Okay, sorry, it's not a cantilever here. I'm having a wall around this place at the ground floor. Another wall will be at the first floor there, here. But this slab here can carry it. I am sure of that. This is just a sit out here. Okay, I'm going to have a wall. Okay, let me check these measurements. This is 150. Yeah, it requires a little critical thinking. Okay, so you have to take your time to think. It will still serve as it is like this. Okay, it's still going to serve as it is like it's going to be even more economical like this. It will carry this store at the first floor conveniently. I am sure of that. So here we can have a beam that goes this way. Around this area is going to be a cantilever. Yeah, it will serve this way. So I can leave it this way. I'm sure it will serve. The span is not that much. We are just having around 1 meter span. Okay, fine. So I'm going to leave it like this, but you can drop a comment if you think there's another way that will make it much more economical. I'm ready to learn or to take correction. So you can drop a comment down. Okay, so I think my general arrangement as it is right now, I think it's okay for me as it is right now. So all I need to do is just to place the columns, okay, and then name the beams. All right. Okay, yeah, you can see I have closed the staircase area. Okay, so it's closed. Okay, good. The next thing here now I'll do is to create a grid. Okay, so let me use the grid from the structural drawing. So I just match property. Okay, if you already love what you're seeing, please just like this video, give it a thumbs up. Okay, subscribe to this channel, is 100% free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, so if you want to actually learn with us, you can actually DM me on WhatsApp, or you can call my line. Okay, like I said, we have covered structural designs, mechanical and electrical service drawings, road designs, water designs, and architectural service drawings. Everything, they are very much available. Okay, so you can come learn with us. Okay, most especially if you are a student, please, I will encourage you to embrace some of this knowledge right now. That you are on strike, please take advantage of some of these trainings and learn. Okay, enroll on these trainings and learn while you are still a student. Okay, so that by the time you are done with school, you are already employable. Okay, So it's not like there are no jobs. There are jobs, but most of the people are not actually employable, and a lot of these companies are not really ready to start training you. So it's important you lay your hands on these things and learn. Go on site, volunteer, you can enroll on internship. That's the only way you can actually grow. So please, I encourage you to lay your hands on these softwares while it is still very much affordable. Okay, lay your hands on them and start learning. Okay, I think I'm almost done with this general arrangement. All right, good. All right, let me check. Okay, so I'll copy this column. So if you are using Prota structure, okay, most especially, please make sure that your columns, the lines, the entire boundary is by a polyline. Okay, you can see I use polyline right now. Make sure it's by a polyline. Okay, if you click on polyline, you can see all the lines are selected. So this is actually an example of what a polyline is. So the inside is just shaded, but it is the boundary entirely is by a polyline. So I will even take off this. I don't understand the way it's showing, it's displaying right now. Sorry, I'm going to take off everything. PL for polyline. I'll type 230, type another 230, and I'll type here 230, and then up here I can type C, enter, it will close. C means close. Okay, let me hash this. Just press H, enter. That's all. So it has been hashed. Okay, if I want to maintain this, since I already have, I can maintain it this way. So you can see polyline. That is actually what the Prota structure recognizes. So it will actually give you as a column. But the moment it's not on polyline, it won't display as a column for you. Okay. So you see here now, I can decide to place this here and forget about this without placing a column here. Okay, so but if I place a column here, it's going to make it more safer, but as it is right now, it's still safe. Why I said it's safe is if you check the span here, you can see this is even less than 4 meters, so the span is reasonable enough and it's going to carry it conveniently, that I'm sure of. Okay, so to make that more economical, I can skip here. That means this beam is going to be acting on this beam as a point load. Okay, so this beam that comes this way is the primary beam. This beam that is acting on this is the secondary beam. Okay, I hope that English is not too strong. I believe you understand that. Okay, so this is a way of just making the design much more economical. Okay, like if you can remember, I said your design has to be safe, and not just being safe, your design should be economical. But you can see here now, I can even as well leave this as a point load on this beam, but let me confirm the span. Okay, so the span is okay. So by the time you run your design in the software, it will now tell you whether there is a beam that has failed or a beam that has passed. So you'll be able to see it in your software. And mind you, there are so many softwares you can use for design. We have Start Pro, we have ETABS, we have ProtaStructure, we have Quick Civil Series, we have RCD 2000, we have RCC Spreadsheet. Okay, the softwares are numerous. Okay, there are so many softwares you can use to achieve your design. A whole lot of them. There are more than hundreds of them. Okay, so you just lay your hands on a particular software that you find very comfortable to actually design with. Okay, I think ProtaStructure is easy. Quick Civil Series is also very easy. Okay, so these softwares are very easy. If you have been following me, I have talked a whole lot about ProtaStructure. I have a lot of videos on ProtaStructure. They are all very much available on my YouTube channel. Please visit the channel and make sure you keep yourself busy. Now you can see this is exactly what I have here right now. Here I'm going to make this stop here. Okay, so let's dimension this. Let's check the dimension here. Okay, DLI continue. Okay, good. You can see the span are not that much. Okay, DLI continue. Okay, this is now going up to 5 meters. Good. So DLI continue. So it will continue the dimension. Okay, now you can see the span is up to 5.7 meters. So this span, what I'm going to do is, if I want to maintain the same depth of beam, because I'm going to be using 450 beam here, please, I will encourage you to get RCD Simplified Reinforced Concrete Design book by Victor O. Oyenuga. I have them very much available. I sell them. You can DM me to get yours. Okay, please, you're going to see you know, from his wealth of experience, he will actually advise you on the depth of beam and all of that. So it is a practical design book. Okay, that's why it is called Practical Approach, okay, to construction. Okay, so it will guide you properly. So if you are going above 5.5 meters, it is advisable you increase the depth of your beam. So right now I'm assuming I'm using a 450 depth of beam for this, but because this span is up to 5.7, it is advisable to increase the depth of this beam along this span to be up to maybe 500 or 550. So if you run your design, it's going to tell you where it passes and where it fails. So here right now, the depth of this beam is supposed to be a bit deeper than the other beams. Okay, so please, I will encourage you, like I said, just lay your hands on those books. Okay, so you'll be able to know when you are going up to 6 meters, your depth of beam should be up to around 550 to 600 depth. If you are going up to 7 meters, it should be around 650 to 700 depth. Okay, if you are going up to around 10 meters, okay, the depth of your beam will increase as well, because there are some designs that from the architectural drawing, they do not want any obstruction most especially when you are designing for like a mosque or a church in the middle, okay, when they are not actually using a steel roof. Okay, most times it is required that where you have larger span, sorry, okay, so sometimes columns are not, they do not really want columns within the span. So in that case, the depth of your beam can be very high. Okay, in that case, the depth of your beam can be high. You may be having up to 1 meter depth of beam. It depends on the span. Okay, there are cases you have even over 1 meter depth of beam. So the span will determine the depth of your beam. Okay, so right now I want to reduce the span. Okay, because me, I always like to maintain the same depth of beam. So you should have what actually works for you. So me, I like to break it. So I'm not saying you must break it, just like what I have explained right now. So you can actually maintain the span, but then increase the depth of the beam. Okay, but there are cases whereby you use the same depth of beam, only that the reinforcement, thickness of the reinforcement is going to be higher, and there is every tendency for you to have this reinforcement very close to each other. So in order to avoid that, the depth of the beam should be increased. Okay, so please lay your hands on RCD Simplified Reinforced Concrete Design book by Victor Oyenuga. Is very much available. You can actually get it from me, like I said. Okay, so you can see right now I am done with the general arrangement. Okay, all I need to do is just to dimension all of this. So let me put in the dimensions. Continue. Okay, so you can see what I have here. Okay, DLI, continue. Okay, put it here. Okay, fine. All right, so I'm going to copy this. Okay, so let me have my foundation layout. Okay, you can see I have copied another one down. Here is just for you to do your slab and beam layout. Okay, okay, let's see. Let me reduce this. Match property. So you can see here I'm using 150 thickness of slab. Okay, let me reduce this cycle. So if you love what you're seeing, please just make sure you like this video, give it a thumbs up, subscribe to this channel. It's actually 100% free. This is actually going to be a one-way slab. If you divide 4780 divided by 2 points, let's do that quickly. Calculator. 4780 divided by 1, what do we have? 2155. 2155. Good. So the value is actually greater than 2. This will actually make this a one-way slab. Okay, so please take notes. When the value is greater than 2, is a one-way slab. Okay, when the value is less than 2, it's actually a two-way slab. Okay, please lay your hands on Simplified Reinforced Concrete Design book by Victor Yenuga. Okay, so this is actually a one-way slab. Okay, so you can see how the indication is. Sorry, it's not very clear because of the color, so I'm going to change it to this color. I think you can see it clearly now. Okay, so this is a one-way slab. Okay, so you are going to be having your main reinforcement spanning going along this. Okay, this is also going to, this is now going to be a cantilever. Okay, around here is going to be cantilever. So this, so some part of this is cantilever, if you can remember. Okay, let me look at this architectural drawing again. Okay, this is a sit out. We have the same sit out, but you know there's definitely going to be a slab here. Okay, so we are definitely going to be having a slab here. Okay, yeah, so but then I don't want to put this wall here. I just want this to be more economical than it is. Okay, okay. I think this is also going to be a one-way slab. This is 2190, so it's also going to be one way. Please, I hope you know how to come about your one way, your two way. Okay, it is ly all over lx. Ly means the longest span divided by the shortest span. Okay, so please make sure you do that. Okay, this is also going to be a one way, so let me copy this there. I'll copy this here, while this one I'll take out this. So the same way you do for this is the same way you are going to do for all of them. Okay, so this that I copied here, I'm going to assume I'm going to assume a 1200 by 1200 column base for race. Good. So let's say my base from my design is 1002 by 12. Okay, please, I'm assuming that. Okay, I'm just assuming that. So it's an assumption. Don't crucify me for that. So let's say I'm having all of them are of the same size of base and the same size of column. Okay, so let's say all of them are the same. Okay, so you are getting all this from your design. Okay, so mind you, please, this is not a design, this is just detailing. I'm not designing right now. I'm detailing. I'm trying to come up with a general arrangement. Okay, so this is actually the main general arrangement. Okay, so general arrangement means structural layout. You are positioning where your columns and your beams should be. So I'm just trying to position them. Okay, so by the time I run the design on the software, okay, or I'm doing it manually, you can do your design either manual design, the one you do normally in school. You can do it manually if you want. You can use softwares. Like I said, there are so many softwares you can use for structural design. Okay, so this is just a structural layout that I'm doing. The structural layout means this, the general arrangement. Okay, you are arranging where your column should be, where your beam should be, where your slab should be. Okay, and then your foundation, and then the type of foundation, all of this. Okay, so you are considering the nature of the soil in order for you to come up with the type of foundation that you should use. Okay, I have talked on all of this in my channel. Please make sure you visit the channel. Okay, by the time I run this design now using either manual or a software, it is now going to tell me the structural members that have failed and the structural members that have passed. So in a case where a structural member failed, I may need to change the depth of that particular structural member, or increase the thickness of that member. Okay, for example, if your beam failed, from what I have done, from years of experience, I can tell you that everything here will pass. Okay, but there are cases whereby you run your design and then a member will fail. Okay, by the time your member fails, you will need to now change that structural member. I believe you have heard of required and provide. Okay, when you are doing your design in your classroom. Okay, so this is actually what I'm providing. So the software that I'm going to use will now tell me whether it has passed. If it has not passed, it will tell me the area that is required, or whatever size that is required in order for it to pass. Okay, good. So these are the foundation. So I'll use ML for multi-line. Okay, so because I'm using a pad and a strip foundation, so this is actually the size of my strip. So this is what I'm doing. I'm creating an allowance for this. So there are cases where, most especially if you are in Lagos, in the island part of Lagos, they do more of raft and pile foundation. Okay, more of that. I believe you have heard of different types of foundation. We have pad foundation, strip foundation, strap foundation, pile and rafts. Okay, all these are types of foundations. So I think Kaduna is blessed. Our soil here is actually very good. So mostly it falls within the range of 150 to even 200. So it falls within that range, so which is actually a good soil. So mostly we use pad foundations here in Kaduna State. I think Kaduna, Abuja, Nasarawa, and I think part of Niger that I'm sure of. I think Kano too as well. Yeah. Okay. Alright, if you love what you're seeing, please make sure you like this video. Just give it a thumbs up, okay? Make sure you subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to get a notification whenever I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, so mind you, I have not finished this one, so you can place it for other ones. So from here I just know that this is definitely going to be a two-way slab. This is also most likely going to be a two-way slab. So please do it. Don't do a guesswork. Make sure you do it right. Punch it in your calculator. Do your ly over lx to know whether it's a two-way slab or a one-way slab. Okay, so you can number this. This is panel 1. Number it. Let's say this is 2. This is 2. Panel 3. Panel 4. Panel 5. So the same way you arrange it here is the same way you are going to arrange it in the software. Okay, 6, 7, and then this is 8. Then your floor beam. Okay, so you name them as well. Beam 1, you name them beam 2, beam 3, like that. You change the name. Okay, let me change this one for you, so that I know that some of us that may still not understand what I'm trying to say. So I name this 2. So in that same order, I'm going to change the names to all of them, okay, and give them their names. Okay, so that is that. This is actually how to come up with your general arrangement. So this is the foundation layout. This is the slab and beam layout. What you are actually going to be having at the top, okay, that's the suspended slab. Okay, is what you are going to be having. This is it. Okay, so if you love what you are seeing, please make sure that you like this video. Just give it a thumbs up. Okay, subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, in order for you just to encourage as many that actually want to have a deeper insight in design. Okay, like I said, if you want to learn from us, please make sure you DM me. Okay, you can drop a message. You can send me hi on WhatsApp, and then I'll be there to guide you through the process.